Okay, so I'll explain what that means as we go along. But your first example, let's say we have, this is example 1, f of x is equal to x to the 6th plus 15x to the 4th minus 241 x squared plus 225. All right, so get out your grapher, type that in your grapher, and tell me what x-intercepts you hit. All right, so when you graph this on your grapher, you guys are seeing 4. How many can there be?
6.
Are any of them bouncers?
No.
Okay, so it went through 4 times and there's no bouncers. So where are the other 2?
Imaginary.
They're going to be imaginary ones, all right? So there should be up to 6, and this is another reason that imaginary numbers exist, because in algebra, we always want to be able to factor down, if there's a highest power of 6 on a polynomial, we want to be able to factor that down to 6 parentheses, okay? So no bouncers, so I know none of them exist twice. I've got 4, so I'm going to have to do synthetic division with the 4 I know to get it down to a quadratic so that I can solve that quadratic. And we're going to make a prediction that when I solve that quadratic, I'm going to get imaginary numbers, okay, or complex numbers. Okay, the complex number system is what we say contains imaginary numbers. So you got what? What 4 did you get?
3, -3, and 1, -1.
So plus or minus 3, plus or minus 1. Okay, so we are going to do synthetic division with those 4 numbers. Okay, and let's see. I'll have to write small on this thing, definitely. So I'm just going to go to the next page so I've got the full screen, and you guys can tell me. I'm going to start with positive 1, okay? Positive 1, and you guys tell me the coefficients. I guess I've got them right here. My power of 6 is a 1, and there is no power of 5, am I right? So I need a 0, and then I have a power of 4 of 15. Third power, I do not have one, so I put a 0. X squared is a negative 241. And x to the first I do not have, so I want to put a 0 in there. And then I have a 225 for my x to the 0 power. No x at all. We got that right? So super important when you're doing these that you check and double check. One little negative sign here throws off a lot as you go along here, because we got to do synthetic division like 4 times. All right, so I'm going to pull the 1 down. Pull the 1 down, I multiply times 1, I get 1. 0 plus 1 is 1. 1 times 1 is 1. 15 plus 1 is 16 times 1 is 0 plus 16. 16 times 1. Now I got to do 241 minus 16. What is 241 minus 16? I believe it's negative 225. Negative 225 times 1 is negative 225. Negative 225 plus 0 is negative 225. Negative 225 times 1 is negative 225. And sure enough, I get a 0. That's what I expected to happen. So that verifies for me, but that this 1 wasn't really a 0.9999 or something like that. Okay? Everybody okay with that? Okay, so I'm not going to go back to the original numbers. I'm going to use my new set of numbers. And this time I'll use the number -1. And it doesn't matter. You can use any 4 of the zeros that we found. I just chose to start with the 1. Okay, so I do this again. I pull down the 1. I get a 1. 1 times -1 is -1. 1 and -1 give me 0. 0 times anything is 0. 16. Negative 16. 0. 0 times -1 is -1. So I get what? Negative 226? Nope, I did that wrong. 0 times anything is 0, right? So negative 225 times -1 is positive 225. 225, and that's 0, 0, 0. Okay, so now I still need to do 3 and -3, right? Is everybody with me? Am I going too fast?
Could you slow down?
Yep, I sure can. This time, let's try 3 with that next row of numbers. 1 times 3 is 3. 3 plus 0 is 3. 3 times 3 is 9. 16 and 9 is 25. 25 times 3, 75. Hang on, my pen is not writing well here. Okay, so 3 times 25 is
225.
75, and 75 times 3 is 225.
Sorry.
You're fine. 225 and negative 225 is 0, and of course I would get zeros all the way across if I continued. Okay, now I got negative 3.
So you have to do all of them that we know?
You mean as far as going clear out here?
Yeah.
No.
Like, so we have to do the 1, negative 1,
Right.
3, and so we have to
Well,
do
I guess
all-
you wouldn't have to. It depends on what your highest power is. Our highest power was a x to the what?
X is 6.
So this is 6, this is 5, this one's 4, and this one's 3.
Both.
So if that was a 2, I would be ready to, I don't
So we
really,
just have to get down to the x to the second power.
yeah. If you can get it down to a quadratic, then you can solve it. Okay, does that make sense?
Yeah.
Okay, so I carry the 1 down. 1 times 3 is 3. 3 plus 3 is 6. 6 times 3 is 18. 25 and 18.
Wait, what?
Is this not right?
Well,
1,
supposed
1
to be
times
negative
3.
three.
So it'd be
Oh.
0.
I couldn't see my negative because I zoomed out here. Okay, so that's a negative 3. That's a 0. 0 times anything is 0. Here I get a 25. 25 times negative 3 is negative 75. 75 and negative 75 is 0. Okay, so now I finally got it down to a quadratic, right? And it's even a pretty easy quadratic to solve. I've got x squared plus 25, because I have a 0x in between those, equals 0. So if I go to solve that, I'm going to move the 25 over, and when I move the 25 over,
Yeah. Oh my gosh.
I get a negative 25, and then I square root a negative, and that gives me the imaginary numbers that we were predicting. Okay? So square root, what am I going to get for my 2?
5i.
Not just 5i, plus or minus 5i. Because I had to have 2, right? So in these problems, there's a thing called the conjugate roots theorem. And the conjugate roots theorem basically says you're never going to have a imaginary number without its conjugate. Okay? If 5i is a 0, then so is negative 5i. Because the only way you get imaginary numbers is by square rooting a negative. And anytime you square root, you get 2 answers, right?
Yeah.
Okay? So the conjugate roots theorem says anytime you have a positive 5i, you're also going to have the negative, which that's just common sense to us, right? Anytime we square root, we enter the square root, we have to put a plus or minus in front of it. All right, everybody okay with that?
Yep.
All right, so
So is this what we did on the worksheet here?
yes. That's just that when you did the worksheet yesterday, you didn't have any imaginary roots.
Oh, so it just.
Okay?
worked out as
So it's the same thing as yesterday, we're just adding in some imaginaries, okay, for this part of it. Okay, so the instructions on this problem, I don't know if I wrote up there, but your instructions were to factor, okay? So I've got these 4 roots right here and these 2 right here, and I have to write that thing in factored form. It was originally given to me in standard form. So now I'm going to take the standard form and I'm going to change it to factored form. All right, so now I have roots. Here are my 6 roots, right? So if I want to write this thing in factored form, it's going to look like this. F of x is equal to x minus 3 times x plus 3, x minus 1, x plus 1, x minus 5i, and x plus 5i. Now you always want to check your leading term. If I multiply all these x's together, will I get this for my leading term?
Yeah.
Yeah, now if there was a 2 here, I would need to put a 2 out front, right?
Yep.
But I don't, it's just an x to the 6. So that's the answer to this problem that you will type in for Hawks. Notice it's 3 pairs of conjugates. Got a pair of conjugates here, pair of conjugates here, pair of conjugates here. You will always have conjugates with the imaginaries. You don't necessarily have to have conjugates with the reals. It just worked out that way on this one. Okay? Everybody good with that?
So you put all of your intercepts in with x.
Yep. And so this one is for this one. They changed, the sign should be reversed.
Yeah.
Okay? All right, everybody okay with example 1? Okay, example 2. Instructions are still to factor. We want to factor f of x equals x to the fourth minus 12x cubed plus 60x squared minus 300x and 875. Okay, and they're going to give you one piece of information. They're going to tell you one of the zeros. This thing has a 0 at negative 5i.
So that means there's a positive.
Ah, exactly. And so there's this theorem. It's called the conjugate roots theorem. It's not important that you know the name, and it's kind of common sense. But if you have a 0 at negative 5i, you must also have one at positive 5i because imaginary roots don't exist without each other. They have the conjugates always come as a pair. If this is a 0, then so is positive 5i. Does that make sense? So this one's given to you. This one we figure out on our own because we know they have to both exist. Does that make sense? You can't square root a negative without getting a plus or minus in your answer.
So for this one, so you find your intercepts and couldn't you just like write your thing?
So yeah, now you're going to type, so now we know two imaginaries, but it's possible that maybe this is going to come out with weird, crazy decimals. So I need to type this in the calculator, and we're going to hope for two nice ones. Okay? 5 and 7. So when you type this in the calculator, you got 5 and 7. Somebody want to confirm that for me? Confirmed. You got it too? Okay, so by the calculator, we find 5 and 7 are zeros. Okay, so, you know, the only thing, if you weren't sure that maybe this on your calculator isn't clear, maybe it's showing up as a 4.99999, okay? If that were the case, then we could do synthetic division to verify that this is a 0, okay? But if we're confident that the 5 and the 7 are right, and we already know these two, this one's super easy because I'm letting you use a calculator to write in factored form. We have x minus 5, x minus 7, x minus 5i, and x plus 5i. And once again, you want to check your leading term. My leading term does not have a coefficient on it, so when I multiply x times x times x times x, I should get x to the fourth, and we'll be fine. Does that make sense? Okay, great. All right, so third example. Example 3. Instructions are the same. We want to factor. And my function is f of x is equal to x to the fourth plus x to the third minus 11x squared plus 209x plus 820. And this time they're going to tell you that 4 minus 5i is a root, which is the same thing as 0. A root means the same thing as a 0, or an x-intercept, or an interval endpoint.
So would negative 4 plus 5i be 8?
All right, so if this is a root, then the conjugate of this should also be a root, okay? So if 4 minus 5i is a root, then 4 plus 5i should also be a root, okay? Or is it negative 4 plus 5i? The conjugate roots theorem says that anytime you have a imaginary root, then its conjugate will also be a root. So it's not negative 4 plus 5i, it's just 4 plus 5i, okay? So 4 plus 5i is also a root by the conjugate root theorem, CRT, conjugate's root theorem. So we're given what's in red, but I can also say that this is a root by the conjugate roots theorem. And if you forget that and you're not sure, then think about what the word conjugate means. Okay, we did conjugates with when we would take x minus 3 times x plus 3. Those are conjugates. Okay. All right, so I know these two roots. Type in the calculator and see if I can find the other two. -5 and what?
-4.
Okay, so by the calculator, somebody confirm it for me. -5 and +4 are also roots?
-4 and -4.
No, they're both negative, okay. Calculator makes this easy. If we didn't have the calculator, we'd have to do, I'm not even sure I could use synthetic division with the 4 minus 5. I think I can, yeah.
Why is Hawks learning? Why do they make you like go the hard route?
All right, so on this one, I'm ready to write it in factored form. So this one's a little weird because I have different intercepts there, okay? So my intercepts, when I write it in factored form, I've got the -5 and 4, so that's x plus 5 and x plus 4, right? And then I have, you have to be careful with this. Basically, you just want to change your signs. So just like you changed the signs of the -5 and made it a +5, you changed the sign on the -4 and you made it a +4, you're going to want to change the signs on both numbers this time. So I'm going to have x minus 4 plus 5i and x minus 4 minus 5i. So x minus 4 plus 5i and x minus 4 minus 5i is the way you're going to want to type that in. Okay? So you're just remember you're changing the signs on everything. You change the sign on this, 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 this, and this.
Wait,
Okay.
so wouldn't it be negative and
So this one's negative positive, this one's negative negative.
I see.
Okay? Does that make sense?
Yep.
And so that will be your answer in factored form. And so when you graph this, you can only see it crossing two places, right? Yet the highest power is a 4. That's how we know if it only crosses at two places, there's got to be two imaginaries in there. Everybody okay with that? All right, so next example. Example 4. And this time the instructions are to find the zeros. Find the zeros for the function, and we will do this function. F of x is equal to x to the 5th plus 7x to the 4th plus 40 x to the 3rd plus 184 x to the 2nd. Crazy numbers here. Plus 375 x plus 225. Okay? So x to the 5th, 7x to the 4th, 40x cubed, 184, a 375, and a 225. So you're going to type that in your graph. The only difference between this one and the last one is now we're finding zeros instead of writing in factored form. Okay? So you just have to type in the zeros. So we can expect this thing to cross the x-axis up to 5 times. So you're going to type this in, look to see if you can find any x-intercepts and if you have any bouncers and that sort of thing. Okay? So type that in there and tell me what you get. We're assuming -1 is not a third power, is what you're saying. You think it's just a first power, goes straight through. Does it flatten out at all?
No.
Okay, so -1 goes through, does not flatten. Okay? And then the other one's what, -3?
Yes.
Okay, and -3, you're telling me is a bouncer. Okay, so I've got a couple of options here. I've got like multiple options here. I've got a possibility of x plus 1 times x plus 3, and you don't have to write these down if you don't want to, but that's a possibility. Do you agree?
Yes.
Because that would give me a 5th power. And this one is a bouncer, but did my bouncer flatten out at all? Did it just bounce and go right back up, or did it flatten out at the bottom?
No, well, I don't know.
I don't know.
So if it flattens, you're right, you can't tell everything by just looking, right?
Yeah.
But if it was very obvious that it flattened out on the bouncer, then this could possibly be a 4th power. Let's see, my other option would be this, a 3 here and a 2 here. Okay, that's an option as well, but in order for this one to happen, this one would have to flatten out as it goes through, and they're not seeing that, okay? So my other option would be maybe it's an x plus 1, a squared on the x plus 3 and then two imaginaries. That's a possibility as well. So it's either this, it's this, or it's this, okay? And I'm betting if you can't see this one flatten out and you can't see this one flatten out, then this is probably the option here, okay? So we need to do synthetic division with the -1, and we need to do it twice with the -3 to get this thing down to a quadratic, okay? All right, so -1 and 3 with the bouncer. So let's start with the -1. Let's get it out of the way. And my coefficients are crazy. 1, 7, 40, 184. We're not skipping any powers, it looks like. And 225. Okay, everybody good with that? Did I get them on there right?
I believe so.
Okay, so let's pull down the 1. 1 times -1 is?
1.
-1. 7 and -1 is 6. -1 times 6 is 40 minus 6 is 34. -34, subtract, I get what, 150? 150 times -1 is -150. Subtract 150 from 375 and I get 225 times -1 is -225. And sure enough, it did come out of 0 even with those crazy coefficients. Is everybody okay with that? All right, so next we need to do, what was our other one?
-3.
Okay, so let's take that new set of numbers and let's do it with -3. So pull down my 1. 1 times -3 is -3. 6 and -3 give me 3. 3 times -3 is -9. What's 34 minus 9?
25.
Okay, so 34 minus 9. 25. 25 times -3. 50 minus 75. 75 times -3. Okay, and there's my 0. Okay, now -3 was a bouncer, right?
Yeah.
So since it was a bouncer, I want to do it again because that means it existed twice, at least twice, right? Okay, so pull the 1 down. What's 1 times -3? Oh, nice. I get a 0 there. 0 there. 25 and 0 is 25, and 25 times -3 is -75, and of course that gives me a 0 as well. So my highest power was a 5, so this one's a 4, this one's a 3, which means I'm now down to the quadratic, and I know how to solve quadratics in any form. So I get x squared equal, or plus 25. This looks familiar. I think I had this in a previous problem. X squared equals -25, so therefore x is going to be plus or minus 5i. Okay, so I now know all of my zeros. Okay, and all the instructions said was to state the zeros. So if I'm going to state my zeros, I'm going to say I've got -1, I got -3. You don't have to write the -3 twice, and then you get a 5i and a -5i. Yes, Copenhagen.
Okay, so when we go back to the x squared plus 25,
Uh-huh.
and so it was x equals the square root of -25.
What happened to my slides?
Well, I'm just wondering.
We said we had a -1 and a -3, a positive 5i, and a -5i, okay? So our highest power on our original problem was an x to the 5th. So why do I only have 4? Because this one was a bouncer, right? And so we call that a multiplicity of 2. In other words, this one existed twice, okay? So if you ever have a question about multiplicity, which I believe will be in the next lesson maybe, or maybe I'll see on the, yeah, we'll have one of those at the end, but that's what that means, a multiplicity of 2. Okay? Everybody okay with that? Okay? All right. Let's do one more of those. So f of x is equal to x to the 5th plus 7x to the 4th.
Is this example 5?
Example 5, yes.
Question.
Yes, go
Going
ahead.
back. So
Yeah.
to write it in factored form, it would be x plus the 3 squared. But then
Yeah, if it did not ask you to write this one in factored form, but if you had to, it would be x plus 1, x plus
where'd the
3
1 come from?
from here.
From the actual.
Yeah, I know, but wasn't that one a 7?
Oh, no, that one was the one. I'm looking at it all.
Okay, that's all right. X minus 5i and x plus 5i. That's what it would look like in factored form. Okay? All right, so on to this example. Example 5, 24x cubed plus 96x squared plus 128x. I'm going to have to shrink this one down to fit it on here. And minus 256. Okay? All right, so type in your calculator. Let's see what we can see. Negative 4 and 1, either one of them a bouncer.
Negative 4.
Okay? And 1 is not. Okay, did either one of them flatten out?
No. One goes straight there.
Okay? Goes right through, doesn't necessarily flatten out. Okay, so same situation. We would do synthetic division with that. So we'll start with the negative 4. My coefficients are 1, 7, 24, 96, 128, and negative 256. No power skipped. 5, 4, 3, 2, 1, 0. Okay? Okay, bring the 1 down. 1 times negative 4 is negative 4. 7 and negative 4 is 3. 3 times that's negative 12, which gives me 12. 12 times negative 4 is negative 48, which I believe will give me a positive 48 if I subtract. 48 times negative 4,
Negative 192.
negative 192. What's 192 minus 128?
Negative 64.
Negative 64 times negative 4 is positive 256. Isn't that great? Okay, so now we do the, what, was it a positive 1 or a negative 1?
Why didn't you do
Well,
negative
why don't you just do the negative?
Oh, the negative 4 was a bouncer?
Yeah.
Okay, let's do it again then. Okay, negative 4 was a bouncer. So we do it again, we get a 1. We get 1 times negative 4, which is negative 4. Negative 1, 4, 16, 64, negative? Yeah. And subtract, and I get a negative 16, positive 64, and a 0. And what was the other x-intercept?
A 1.
So 1, 1, 0, 0, 16, negative 16. Okay, so this is one where you were asking about last time. What if we had something other than a 25? If I've got x squared plus 16 equals 0, then what's my other two zeros?
Plus or minus 4i.
Yep, x is going to be equal to plus or minus 4i. So you have to list your zeros. So your zeros are positive 1, negative 4, positive 4i, and negative 4i. And this one had a multiplicity of 2, and that's why you only have 4 instead of 5. Okay? Does that make sense?
Yes.
Wow, this is so easy.
How do you say that
I
now?
know, I think this is
I
my
know,
favorite
wait.
lesson so far, but it's going to get longer.
Oh, wait, can you go back, please?
Yep.